Okay, so a point O is at the foot of a plane which is inclined at an angle alpha to the horizontal. Let's draw a good diagram. There's the horizontal, and this is the point O here. Particle is projected with speed v from O at an angle of theta to the horizontal. All the way around there is theta, and moves in a vertical plane containing the greatest line of stroke. It strikes the inclined plane horizontally it's there horizontally. Express tan theta in terms of tan alpha. So let's write down what we know. We know if this is x and y, we know that x equals v cos theta t, and there's no acceleration in the x direction, and y equals v sin theta t minus a half g t squared. And we know that x dot equals v, so that's the speed in the x direction, v cos theta, and y dot equals v sin theta minus gt. That's v equals u plus at. No squared there. So we know that it hits here horizontally, so we know that y dot is 0. So when it hits, y dot equals 0. Excuse me. Therefore, 0 equals v sin theta minus gt. T equals v sin theta over g. Okay. And also to hit the plane, So when it hits, also when it hits, the y value divided by the x value equals tan alpha. Because it's got to hit the slope. Now that was prompted by it talking about tan alpha. So let's have a look at this. So the y value is v sine theta t, which is v sine theta g minus a half g v sine theta over g squared over x, which is v cos theta t. Well, I probably could have done this a bit nicer. That's v sine theta over g. So we've got v sine theta over g, v sine theta over g, and one of those v sine theta over g's. And that g goes with that g, and this is what tan alpha equals. So tan alpha equals, and that v goes with that v goes with that v. We've got sine theta minus a half sine theta over cos theta. So tan equals a half sine theta over cos theta equals a half tan theta. Let's just get the question the right way around. So it says express tan theta in terms of tan alpha. Therefore tan theta is 2 tan alpha. It feels like there might be a quicker way of doing that. Maybe if you come across that, you can add a comment to the video. Okay, we're now going to move on to the second part of this, which was to find the distance up the plane to the point of impact is such and such. Okay, so distance up the plane to the point of impact. So the distance up the plane I kind of see as Pythagoras is my. So the distance up the plane, let's change this to blue because we're doing a new question. Distance up the plane is the square root of x squared plus y squared, which equals the square root of v squared cos squared theta t squared plus, and this is the horrible bit, v sine theta t minus half g t squared. Okay, and from here I think it's just going to be it's just going to be a kind of algebra question. So is the square root of and there's v squared cos squared theta t squared is v squared sine squared theta over g squared plus v sine theta t minus half g t squared. And it's all of that square rooted. Okay, so I'm still going. I'm going to tidy this up a bit. So it's the square root of all of this. V to the 4 over g squared. And that actually comes out of all of it. So we've got cos squared theta, sine squared theta, plus, so all of those have all sorted themselves out, all the g's, so we've got sine squared theta minus a half sine squared theta squared keep going. I think we're on track here. So we take this bit outside the square root and we get v squared over g. Looks good. Okay, but then we've still got the square root of cos squared theta plus, cos squared theta sine squared theta. And we've got a half, this is a half sine squared theta, so we're going to square that and we're going to get a quarter sine to the 4 theta. So looking at what I'm trying to get to, I want to get some tan thetas involved, so I can turn those to tan alphas. So we're going to go v squared over g square root, and I'm going to divide by cos to the 4 theta. So that means I'm going to get tan squared theta plus a quarter tan to the 4 theta. So I've divided that, so I've got to times it by cos to the 4 theta. So there's a cunning little bit of algebra just to get the tans in the right place. So I can now switch these v squared over g square root and tan theta is 2 tan alpha, so this is 4 tan squared alpha plus this is 4 tan to the 4 alpha and we got this cos to the 4 theta. Okay, so the 4 is nice, the tan squared is nice, so take the 4 outside and I get 2. Take tan squared alpha outside, I get tan alpha, so I've got v squared tan alpha over g. And this is all getting closer, the square root, and what have I got left inside? I've taken the 2, so I've taken a tan squared, so I've got 1 plus tan squared alpha. And I've got cos to the 4 theta. Now, this is where I'm going to have to use some algebra that's beyond a bit of M1, the trig identities, but it's within core 4. So what we're going to say, so we've got 2v squared tan alpha over g, the square root of 1 plus tan squared, well that's sec squared, 1 plus tan squared is sec squared alpha, and cos to the 4 is sec to the 4 theta. That's right. So this can now come out, and I've got 2v squared alpha over g. I can bring a sec alpha, and we're gradually getting closer. And then we have the square root of, well actually the square root of sec to the 4, so the sec goes completely, so we've got sec squared theta, so the square root is now gone. We're closing in, equals 2v squared tan alpha sec alpha over g, and sec squared is 1 plus tan squared theta, and tan squared theta is 2 tan alpha, so I've done bad here. I've just said that cos is equal to sec. That's not true. It's 1 over sec. It's 1 over sec squared. It's 1 over this. V squared tan alpha sec alpha over g times 1 over 1 plus 4 tan squared alpha equals final 2v squared tan alpha sec alpha over g brackets 1 plus 4 tan squared alpha.